Good morning, sixth grade. Hopefully, you guys had a great night. Yesterday, we worked on 11-3 polygons. Today, we're working on 11-4 translations and reflections on the coordinate plane. So let's see where we can find that information. We're here up on our Google Classroom. Go over here to the classwork. Scroll down here to chapter 11. When you pull that up, here are your completed notes here. You can either use the completed notes or the uncompleted notes to follow along with this lesson. So let me pull up the notes here and see what we have here. So for right here now, chapter 11, section 4, translations and reflections on the coordinate plane. So basically, what we're going to be dealing with today are two types of transformations, okay? The translation and the reflection. Well, let's see what we have right here. Translation. So it says a transformation. Now we're dealing with the transformation now. Is an operation that maps an original geometric figure onto a new figure called the image. So basically, we're starting with our original image and we're transferring that image to a different location, which should be exactly the same. So it says for certain types of transformations, the original figure and its image are congruent. Okay, congruent means that they are equal to one another. Okay, congruent figures have the same size and the same shape. Okay, so the shape has not changed, the size has not changed. All we've done is we've changed its location. It says two common transformations on the coordinate plane are shown. So we're going to look here on the coordinate plane. What are the two basic types we're going to be talking about today? So as you remember the coordinate plane here, it's this here. We have our y-axis here and we have our x-axis here. And we're going to move this shape across maybe the axis, the y-axis, maybe across the x-axis. We're going to reflect it across things. We're going to slide it. There's lots of things we're going to be doing. Well, let's first talk about our first transformation, which is a translation. A translation is also called a slide. So we're basically taking an image and we're sliding it someplace. We're keeping it that it looks the same, but we're sliding it, okay? Compared to reflection, think of a mirror. It's sort of flipped, okay? So the translation we call a slide. The translated image and the original image are congruent, which means they have the same size, the same shape, the same look. Everything is exactly the same. They are equal to one another. The orientation, which means it's flipped or changed. The orientation means it is staying the same. Okay. So if it's a trapezoid that looks like this, let's say, when we move it, it's still going to look like this. Okay. Compared to reflection, it may flip upside down. Okay. Where the reflection, which I just said here, is called a flip also. Okay. The figures are mirror images of each other. It's basically you looking into the mirror. When you lift up your right hand in the mirror, actually your left hand goes up in the mirror. Okay, the reflected image in the original figure are congruent, which means they are still the same. They have the same shape, same size, everything. They are congruent, but the orientation is different. So it may be flipped. So that's what we're going to be looking at here. Scroll down here now. So it says, let's look here at a transformation here. Here is an example of a transformation. Well, if you remember, we called this a slide, okay? So a transformation is when you slide, okay? We're going to slide a figure from one position to another position. So as you see here, we start without turning it. That's going to be key here, without turning it. So as you see here, here's our original, this B up in quadrant 1. If they want us to do, they want us to slide this, and we slide it down to our new image right down there. Okay, so what we did, we slid this image across. As you notice, it's exactly the same size. It's exactly the same shape. It's exactly the same orientation. Nothing has changed, but really its location. Now let's look at the reflection here. Okay, we talk about being a flip. Okay, a reflection is when you flip. Okay, so that's what we talked about here. It's a flip of a figure over a line. So we're either going to flip it across the y-axis, or we may flip it across the x-axis, depending on what we are being asked to do. This line is called the line of reflection. Well, this is what we're flipping across here, the y-axis right here. So this axis here is known as the line of reflection because we have flipped it across the line of reflection. It shows right here the y-axis being the line of reflection. So what we originally did, we started out with the B over here on the left side of the y-axis. We flipped it to a mirror image over on the right side of the y-axis. And as you see, they are still the same size and same shape. It's just that the orientation is different. Okay, let's continue on to the second page here. Now, it says, when translating a figure, every point of the original figure is moved the same distance and in the same direction. Okay, let's look over here first. What do I have here first? Over here, I have prime. Okay, and what we mean by this, and I think we've talked about this before, I cannot have, we want to know, okay, what is figure A? Okay, if I have point A, which is located right here, this is my original point, okay? Well, what happens if I move it, okay? This one here says we're translating it 5 units to the right. Well, I don't want to call this new point A also because I can get it confused because I'm not sure, hey, where was my original, where is my new? So we use the prime symbol, and it's right here. It's that little hyphen right there that we use to say, hey, this is our prime. Okay, so what we do here is that we say, okay, let's follow along here. We want to translate this original image here. Here is my original image right here, okay? We have rectangle A, B, C, D, and they want us to translate this figure 5 units to the right. So I have to take each one of these points, point A, point B, point C, and point D, and move it 5 units to the right. So if I'm at point A, I need to move it to A prime. Well, let's see how far I have to move it. Well, here's 1, 2, 3, 4, 5. I just moved it 5 units to the right. So I come over here and I label this new point A prime and I put my dot. Okay. I do the same thing with B. 1, 2, 3, 4, 5. And now here is my B prime. Okay. So I have my new point for my A prime, my new point for my B prime. So now I do this same thing with D. I move it over 5 points. Okay. And actually, it looks like they got this wrong on here. This should actually be point D here. So fix that on your notes here. This is point D here, and this is going to be C prime here. So we have D prime here, okay, and we have C prime here. For some reason, they flipped it around. But I had to move D over 1, 2, 3, 4, 5. That made my D prime. And then I moved my C over 5 places. 1, 2, 3, 4, 5. I put my points in there. I label my primes, and you're good to go. We have now translated this 5 units to the right. Now, let's look at translating 4 units up, which means, hey, we're going up from our original. So we can pick any point to start at. This is my original shape here because as you see, it does not have any of the primes. So what we're going to do here is move each one of these points up 4. So if I start with K, move it up 4. 1, 2, 3, 4. There we go. There's my K prime right here. Let's move up the J. Move it up 4. 1, 2, 3, 4. There's my J right there. Go over here to my L, move up my L, 4. 1, 2, 3, 4. There's my L prime right there. And move my M up. 1, 2, 3, 4. M prime right there. Put your dots, connect your points as you have here. And then you have your new image here. Okay, this is your prime image. Okay, now this one is asking us to do 2 things. Okay, we're going to move left 3 and we're going to move down 5. Well, here's my original right here. So here's where we are starting. So let's start here with the R. Okay, it says, hey, to move it R, I have to move it left 3. So I move it left 3. 1, 2, 3. Now it says move down 5. 1, 2, 3, 4, 5. Right here. Here is my new R prime right here. Okay, let's do the same thing with the S. Move it left 3. 1, 2, 3. Then it says move it down 5. 1, 2, 3, 4, 5. Here we go. Here is my S prime. Okay, we'll do the same thing with T. Move it 3 to the left. 1, 2, 3. Then move it down 5. 1, 2, 3, 4, 5. Here's my T prime right here. And finally with the U, move it left 3. 1, 2, 3. Down 5. 1, 2, 3, 4, 5. There we go here. Then connect your points, and this is your new prime image here. Okay, very good. Now, what if we wanted to do it into some type of an equation form? Okay, so let's move on to this next point. It says, you can describe the translation using an ordered pair, A comma B. For example, a translation of 3 units left, okay, and 5 units down can correspond to, okay, we're going left, that's -3. We're going down, that's -5. Okay, so it says a translation moves every point P, which is our point, our ordered pairs x comma y, to the image the P prime, x plus a, y plus b. So basically, all that I'm doing here with this is my this is going to be my A. I'm going to plug that in right here. So it's going to be whatever my x point is, plus -3, and then take for my y, this is my b here, and it's going to be whatever my y point is plus -5, and that will give us our new location. So let's look at some examples here. Okay, so scroll down here. It says rectangle JKLM on the coordinate grid at the right represents a rectangular table on a tile floor. If the table was moved 2 units to the right, so that means we're going to the right too. If we're going 2 units to the right, that's a +2. And 1 unit down. Since we're going down, that's going to be a -1. It says find the coordinate of the vertices of the table's image. Okay, so let's look and see what we have here. As you see, we have our original image here, which is this image right in here. That's our original. Now, what we're going to do, it says, hey, we're going to move this unit to the right too. Since we're moving it to the right too, remember, right or left deals with the x-axis here. Up and down corresponds with the y-axis. So we're moving it 2 units to the right. So we're going to take our x point, whatever that point may be, and we're going to add 2 to that. Then we're going to take our coordinate, whatever that is, and we're going to subtract 1 from it, or plus -1, and that will give us our new ordered pair. So let's figure out what we have here. Basically, it says, okay, if we look here at M is going to be located, if I look here, is at -8. This is -8 here for my x. This is -8 here, okay? And it's also located at +5. So my M is going to be -8, +5. Now it said, hey, with my x, I have to add 2. So -8 plus 2, okay? And then that's going to give me my right hand, my movement. But then we're moving it down 1. So it says take your y, which my y is +5. There's my y here at +5 here. Okay, and I'm going to be subtracting 1 from that, and that's going to give me my M prime. So -8 plus 2 is -6. Then my y coordinate is going to be my 5 minus 1, which is 4. So my new location of M prime is going to be located right here, okay, at -6, 4. Then let's look here at J. J, the location of J, the X location right down here is at -2. So this is -2 here. Okay. And my Y location is once again at 5. Okay. So once again, I have to move it right +2 down 1. So start with my X coordinate, which is -2 plus 2, gives me my new x coordinate of 0. And then take my y coordinate, which is 5, subtract our 1 because we're going down 1, which gives me 4. So my j prime new coordinate is going to be 0, 4. Let's go over here to k. Let's start here at k. So it looks like my original location of k is at -2 for my x, and over here is at 1. Okay, is at 1. So my original is at -2, 1. So now, once again, we're moving it to the right, 2, and down 1. So for the x, I'm going to add 2 to -2, which will give me my 0. I'm going to subtract 1 from my 1, which will give me 0 also. So k prime is located right here at the origin. Finally, do our last one here, L. L works exactly the same way. Location with the original L right here is at -8, 1. Since it's -8, 1, we're going to the right 2. So -8 plus 2 is -6. Then we're going down 1. 1 minus 1 is our 0 here. So we now have our L prime at -6, 0. Plot our points, connect our dots, and we have our translation. Okay, let's look here now. This next one here. Scroll up here so we can read it. Okay, move myself over. It says, suppose triangle ABC is translated 4 units right. Okay, we're going to the right 4. Since that is 4 units right, then hey, guess what? That's going to be +4. And then also we are going down 5. So we're going to subtract 5 from the y. Okay, so let's see what we have here. Here is our original shape here. This triangle sort of tilted on its side a little bit. We're going to translate that now. So if we were to translate that, let's see what we have here. Move this up a little bit, give us some more room here. We're going to start with A. So A is located at -3. Here's my y-intercept here. Sort of hard to see coming right down here. And here's my x-axis and my y-axis right there. So as we can see right here, it's at -3. Okay. And up here, it's at 7. Okay. So my original location of point A is -3, 7. We are going to translate it to the right first 4 places. So I have -3 plus 4 is +1. Then we're going to move it down. So our original location on the y-axis is at 7. So we'll do 7 minus 5 is 2. So A prime is located right here at 1, 2. So we would place that point there and label it as A prime. So with B now is located at -1 for the x and 0 for the y. So that's the original for the B. So now let's move it to the right. So we're going to do -1 plus 4. So we're moving it to the right 4 places. -1 plus 4 is 3. And then if I'm at 0 and I'm moving it down 5, I'm moving it down 5. So 0 minus 5 is -5. So B prime is located at 3, -5. Now, -5 can't get to it down here. So get an approximate where you think where -5 is for the y-axis and plot your 3, -5. Let's move over here to C. Okay, here's our C over here. C is located at 5, 5. That's its ordered pair right here for the original C. So right now we're moving it to the right 4. So we're going to add 4 to 5, which gives us our 9. And then finally, we're going to take our 5 minus our 5, which is 0. So C prime is located at 9, 0. So these are different types of translations on how we move them right, left, up, and down. So now let's look here at a couple things dealing with our reflections. Okay, this is important to understand here. Our reflections are still congruent, but the orientation is different. So let's talk about the reflection. It says, when reflecting a figure, every point of the original figure has a corresponding point on the other side of the line of reflection. Okay, so depending on where our line of reflection is, whether it's the x-axis or the y-axis, there's a corresponding point that goes with the original point. Corresponding points are the same distance from the line of reflection. I'll show you what I mean by that there. So let's say right here, this is very important to understand. Let's say we are reflecting this. Okay, we are reflecting this across the x-axis. So here's our x-axis right here. We have to reflect this image here across the axis here. So it says the x-axis remains the same. So I'm sorry, not the x-axis. The x-coordinate remains the same. The y-coordinates are the opposite. Okay, so if we take a look here, let's take a look at this point here. This point here is located at 3, 4. Okay, since this point here is located at 3, 4, and we want to reflect it across this x-axis here, this rule says the x-coordinate remains the same, okay, but the y-coordinate is the opposite. So if I have the ordered pairs 3, 4, the x-axis, the x-coordinate remains the same. So if I reflect it, the x-coordinate remains the same. So my x-coordinate is still going to remain 3. But it says the y-coordinate is going to become the opposite. The opposite of positive 4 is negative 4. So right here is my new coordinate right here. We have reflected 3, 4 across the x-axis, and its new coordinate is 3, negative 4. As you see, the x remained the same, the y became the opposite. Let's look over here at 4, 4. At 4, 4 here, it says, once again, the x-coordinate remains the same, so the 4 remains the same, and the y-coordinate becomes the opposite. So the y-coordinate here is 4, so it has to be negative 4. So our new location here is 4, negative 4. And as we had set up here, the corresponding parts are the same distance for the line of reflection. So the x-axis is our line of reflection. If I just go up here, 1, 2, 3, 4, 5, let's see, 5, see, 1, 2, 3, 4. No, only 4. I got that wrong here. This point here should be 4 away from the line of reflection, which is our x-axis also. 1, 2, 3, 4, which it is. So they are exactly the same distance away from the line of reflection. Let's take this point here, 2, 1. So x remains the same. So our new ordered pair for the x is still 2, but the y becomes the opposite. So we have 1 here, so this has to be negative 1 here. So the point is right here at 2, negative 1. The same thing applies for this point here at 5, 1. The x remains the same, still at 5. The 1 becomes a negative. So our new ordered pair is 5, negative 1. Connect all of your points here, and it has been reflected across the line of reflection, which is our x-axis right here. Okay, let's look over here at this one here. Now, we're going to reflect it across the y-axis. Here's the y-axis here. So what do you think the rule is going to be? Correct. The y-axis is going to remain the same, but the the y-coordinate is going to remain the same, but the x-coordinate is going to become the opposite. Okay, so let's see what we have here again. Let's start over here. Let's reflect it across our y-coordinate right here, our y-axis right here. Let's start here with 3, 4. So with 3, 4, they said, hey, the x now becomes the opposite, but the y remains the same. So the opposite of 3 is negative 4. The y remains the same, so the 4 remains the same. So we have our new point here at negative 3, 4. Let's go to this point here, 4, 4. Well, they said, hey, x becomes the opposite. So opposite of 4 is negative 4, and the y remains the same. So our new coordinate here is negative 4, 4. Let's go over here to the 2, 2, 1. The x goes the opposite, so that's negative 2. Y remains the same. New coordinate is at negative 2. Over here, 5, 1. X becomes the opposite, negative 5. Y remains the same, so I get negative 5, 1. Connect your points. Yep. Connect your points here. And then we have our reflected shape. Okay, so let's see what we got here now. Scroll down, almost done here. It says to reflect a point over the x-axis, use the same x-coordinate and multiply the y coordinate by -1. Okay, that's all we're doing. We're just saying, hey, it's the opposite. To reflect a point across the y-axis, use the same y and multiply the x by -1. But basically, it would say just do the opposite. Okay, so if we look right here, it says the vertices of the figure D, E, F, G are D is 4 comma -2, E is 5 comma -5, F is 2 comma -4, and G is 1 comma -1. Graph the figure and its image after the reflection over the y-axis. So our line of reflection is the y-axis. So what does that mean here? That means the y-coordinate remains the same and the x-coordinate becomes the opposite. Okay, so let's take a look down here, see what we have here. Okay, so here is my original shape here. Boom, right here. That's our original here. So what they want us to do is reflect it across the y-axis. If you remember, we just said the x is the opposite, the y remains the same. So here we go. We've got 1, -1, okay, for the g. So the g prime is going to be at -1, -1. So we put our point here at G for our G prime. Let's go with the D. The D is 1, 2, 3, 4. 4, -2. So if it's 4, -2, it has to be -4, -2. So there's our D prime right there. Let's go with our E. So we're here at 5. And then down 1, 2, 3, 4, 5, -5. So positive 5, -5 is the coordinate of E. So E prime is now going to be -5, -5, and there's our E prime right there. F is going to be -2 because that's our first coordinate, -2, 1, 2, 3, 4, -4. So 2, -4. So the opposite of 2 is -2, -4, and here's our F. And we will then connect our lines here, and we have our reflected image right here. Let's look at our last example here. Okay, it says the vertices of figure MNOP are M is -8, 6, N is 5, 9, O is 2, 1, and P is -10, 3. It says graph the figure and the image of the figure after the reflection over the y-axis. We're doing the y-axis again. Doesn't look like we have an x-axis here. So since we're doing the y-axis again, the y-coordinates are the same. The x-coordinates are the opposite. So let's see what we have here now. Let's start. Now, as you see here, we're going to have some overlapping just because of how this shape is. So let's start here with our M. Our M, as you see, is located at -8, 6. So M right here, -8, 6. Boom, here's our new location. There's our original location here. So since we're going across the y-axis, okay, the x becomes the opposite and the y remains the same. So the opposite of -8 is +8 and the 6 remains the same. So here is my M prime here. Put a dot right there and go from there. Okay, let's look at the N. N is at 5, 9. So right here, 5, positive 5, +9. There's my N there. Let's get our new N, which our N prime, which is going to be at -5, 9. Right here is our N prime. Let's go with the O. O is located at 2, 1. Here is 2, 1 right here, our original 2, 1 right here. So to do our prime, O prime, it's going to be -2, +1, -2, +1 located right there. So last point here, -10, 3. -10 way out here, 3 right there. There's our location of P. So P prime is going to be the opposite of -10, which is +10. Y stays the same. So it's going to be 10, 3 right here. So here, I'll show you my original first. We'll do the original in green. The original was right here. Okay, up here and down here and across over here to P. Now we'll do our prime. Here's our prime right here. we have reflected it across the y-axis. And as you see, it does intersect with the original. That's okay. But one thing you want to check is, hey, are my distances correct across the y-axis? Let's take the n here. Here's my original n. It's 1, 2, 3, 4, 5. It's 5 units away from our line of reflection, which is the y-axis. So let's see what it is here. 1, 2, 3, 4, 5. Yes, it is the same distance away. So we have reflected that properly across the y-axis. You can do the same for M, do the same for P, and do the same for O, and that will tell you if you are correct or not. So guys, if you struggle with any of this concepts, please rewatch this video. Other than that, guys, get started on your homework. Check your answers also on your Google Classroom, and tomorrow will be a catch-up day. So you guys take care, have fun, and work hard. Talk to you later. Bye-bye.